Hello, David Dominesi here. Welcome to the shop and thanks for showing up today. What we're going to be doing today is taking our bars that we have squared off. These are aluminum, obviously, 6061 T6. So that's slightly hardened aluminum. And we're going to be turning our previously squared off stock into this shape here. So it'll be a good video to show the slotting and ending up with this thin profile here and trying to make it look nice, have a good surface finish like that, and also to be fairly accurate from this side to this side. This should be about between 125 and 130 thousandths, and it's pretty close all the way down. So we need to start with stock that's pretty accurate, and we'll measure this in a moment to see how we've done. Used a fly cutter for this, the Tormach fly cutter. That's the Tormach fly cutter there. That's the 3/4 inch shaft, and the insert I'm using, or did use, is their very sharpened carbide insert made for aluminum. Boy, that works good. This is our squared off stock, 1065 and a half. .1063, so 2/1000 over 16 1/4 inches. $16.94, 16.96. So that's squared off quite well. And we're going to turn it into this slotted piece here. We want a good finish, and we want it to be accurate in the end. This is the critical part here. Let's see. 1026. .029. So that's pretty good for 16 inches and within spec. We're going to be using high-speed steel and carbide. The first one is a 3/4 inch 2 flute by Niagara, and then we're going to switch to carbide. This is by OD Tools Incorporated. That is a high helix. See that spiral flute there? High helix and 2 flute. That gives us a lot of chip clearance for milling aluminum. This will run with kerosene or WD-40. This will run dry when we're climb milling, and when we do conventional milling, we'll use some WD-40. I'll show you how good that works a little later on. We'll be using our tree mill, and the first thing we need to do is indicate our stock into the vise. We'll be using the stare at last word indicator. These are soft jaws that I machined after I connected them to the vise. So in this spot on the table, they're very flat in relation to the spindle. We're going to check everything for burrs. You can draw file gently, knock off any burrs on the part that's going to be settled down into the vise. Use your hand to check. You can feel 1 or 2 thousandths with your fingers. Make sure your jaws are very clean. A piece of paper is generally the thickness of 3 thousandths. So you can imagine if you set your work on a little chip, it may lift up a few thousandths. Now these are not professional jaws. They do okay for this work. I could have made them better. I'm not a professional machinist, as you can tell. I'm just a hobby guy. Now I'm going to press down on the work, clamp my jaws. Now because our vise jaws are so long, they're 18 inches, they're hanging way out at the end, there's a crack here. You can see how it's tight, and then there's a crack. And that crack is several thousandths on each side. So you're not pinching the work on the ends. So you got to use some sort of clamp. I like the cant twist clamp. Put that right on the end. And we'll clamp that down. Now, you won't see that gap disappear because we're touching the work at the bottom of our groove, not the top. That's how this side ends up. Put our clamp over here on this end. Now we're very tight all the way across. Okay, well, this is our speed handle. I like to take it off to get the thing out of the way. Now we'll indicate the work in. Now we're not going to indicate exactly all along the work here. I didn't machine the top, didn't need to, so there was no use wasting the time. So this is an extruded top, and you could have variations from this end to the other end as little waves along the length. So I'm going to indicate this end and the other end, and not in between. That'll make it level from here to there. So let's lay our indicator down and get some pre-tension on it. We'll probably be way off to begin with. That's about 15 thousandths. We'll speed it over to the other side. And it looks like now we're going down. You see there's a dip in that extrusion. And on this side, we're about 3 thousandths lower on this side than the other side. So we'll take a dead blow hammer, okay, and we're going to wrap the other end, the opposite end, half of the distance that we're off. 3 thousandths is pretty close. So I need to tap 1.5 thousandths. That'll be difficult. Gotta go slow. Take it easy. Let's count that. So we'll swing over to the other end now. I'm using the rapid feed on the tree mill. Let's see how we look. Now we're not paying attention in between. We just want to go from end to end. Okay, now we're at 10, and we were at 13. This end's low again, so we're going to raise it up just a little. Okay, and now let's get into a nice number. Notice I go down on the knee and then back up ever so slowly. Let's stop right there. Now let's rapid it over. The rapid on the tree mill is 70 inches a minute. It's variable depending on how hard you pull this little lever over here. Okay, let's see where we are. Looks like over here we are low again. We're dealing with just a few thousandths. Let's try that. Looks like we've got our indicator now about at 12. Now we'll wrap it over and see how close we are to 12 on the other end. Imagine if you had to crank that handle by yourself. You'd need a break when you were done indicating. Now we are dead on. And so now we're indicated in, and our work is accurate in relation to the spindle of the machine. So we can make pretty accurate work now. Let's get our last word indicator out of the collet. We'll have to change our collet size. Right now we're at 3/8. We need a 3/4 inch. There's the 3/4 inch double taper collet. We'll bring our cutter in. We don't want to put it up into the flutes, but we want it up as far as we can get it. And we'll lock our quill. So this is the cut we're going to make first. We're going to gouge this out right here over to there. So we need to move our cutter 130ths, 540 thousandths, and we'll meet up at that spot. We want to leave work here for finishing at the end. That's 670 thousandths. So what we're going to do is find the edge and move our cutter to 640 thousandths, and that'll leave 30 thousandths for cleanup. And then we have to come down to this spot, and that's here on my little cheesy drawing. I've had to make some changes and other things. So our overall length is 1 inch and 690 thousandths, and the top of this part is 400 plus 408, which is 808 thousandths, which leaves us with 882 thousandths. So our cutter will go over 670, down 882. To leave room for cleanup, we'll go over 640, down 882, and then we'll switch our cutter to the 3/8 carbide. We'll be running this cutter at about 3,000 RPM, so let me get that set up. So that's about 3,000 RPM. Now we're going to have to find this edge right here. A lot of different ways to do that. I'm going to be removing this stock, so what I'm going to do is just come over with the cutter and kiss the work, and that'll be my edge. So we can take it and put it on the largest part of our cutter, move our work up and touch it, and then back off just a little bit. Make sure we're not going to hit it. Now we can turn our cutter on and move the work into the cutter until we just barely touch it. Move very slowly. Now you can see we just touched it. Let's zoom in on that. It's right there. Change the camera angle and you can see it. Okay, there it is. We just barely touched the work. We'll count that as 1/1000ths. And we need to move in 640. So let's zero out our crossfeed. Remember, we already have 1/1000ths. And we need 640. Everything's out of the way, so we'll do 2, 4, 600, and 10, 20, 30, 40. Now we'll find the top of our work by starting the cutter and moving the knee up till we kiss the top. This is not critical because we'll be using a depth gauge to find our 882. Give her a couple 100,000ths to start. Our WD-40. We're running at 16 inches per minute. Our first cut is 200 thousandths. Our next cut will be 300 thousandths. Just because we can. Get our WD-40. This keeps the aluminum from being welded back onto the work or onto the cutter. We're going to need our chip shield. We'll be making some serious chips. Okay, we'll do 200 or 300 thousandths back the other way. You've got the idea. When we're down to 882, we'll come back. Here's an idea of the chips we've been making. Boiling hot. And they're beautiful. Hopefully most of the heat stays in our chip. We've made a few chips during this job, for sure. Now we need to measure our depth, clean it up real good. And because of the cutting, we have a significant burr here. So we'll take a deburring tool and peel that burr off of there so it's nice and smooth. Okay? Now this job needs to be close, but it's not that critical. We could use a micrometer depth gauge. But we'll just use a set of calipers with a depth gauge attachment. Hold that on there level, and then we'll just push our deal down there. We've ended up with 827, and we need 882. 55 thousandths to go, so let's zero out our knee. And we should, on a critical job, creep up to this measurement, but this can be off 15 thousandths, so it really doesn't matter. We need 55 thousandths. Close is fine for here. 10, 20, 30, 40, 50, and 5 thousandths. And now we'll relock the knee. The cross feed is already locked, the Y. We're going to lock the knee. We'll lock every axis we're not currently using. Let's get this cut, and then we'll change to our carbide. Okay, we're going to make a slot in here, but we need to move the cutter to allow for 130 thousandths of a piece left here. So we're going to do the same thing here. We're going to touch our work, see how the cutter's not touching, and then we're going to put put it to the largest part of the cutter, move the work in until it does touch, and then back off very little. Make sure it's not touching. We'll turn the spindle on and kiss the work. Just kissed there. Barely, right there. That's about 1/1000. There it is, right there. Okay, so we need to move the distance of the cutter, which is 375 thousandths or 3/8, plus 130 thousandths, and then maybe 20 thousandths more to leave room for cleanup. 375 thousandths plus 130 thousandths is 505. And our kissing is 1/1000ths. So 505. 2, 4, there's 500, and 5, and then we're going to leave 20 thousandths for cleanup. 5, 10, 15, 20. Let's get to cutting. Since this is a carbide cutter, we want this baby to be moving as fast as we can possibly get it. And we can go to about 3,300 RPMs. That's it. And we'll lock it. There's a lock in the back here so it doesn't slip. This will vibrate and get slower as you go if you don't lock it. Okay, we're going to find the top of the work here. That measurement isn't critical because we're going to use a depth gauge from here down to the bottom of our slot. Needs to be 1 inch and 290 thousandths. Since this is a slot, we got to be careful. We're going to be moving at 16 inches per minute, 3,300 RPM, and we're going to have to use air to keep the chips out of there. Our high helix and 2 flute is going to help a lot with chip clearance, but we still need to evacuate the chips continuously. So let's get that set up. This is the system I use. We've got a machined hex nut, magnet, 2 ports for flexible arms. For this job I have that one taped off. I'm just using that one with these twist locks. And I clamp it to this flat part of the spindle. Just like that. And I can drag this down, put it right where I want it. I've got it hooked to shop air, so I've got air right there. Beautiful. We're going to run 50 thousandths or so at a time. We don't want to break our cutter. That carbide breaks so easily. And these chips are hot like there's no tomorrow. Let me tell you. We'll watch this work here. If you use lubricants on your carbide, you need flood lubricant rather than misting or spritzing, because when the carbide gets super hot, if you cool it down with a spritz, you risk cracking it, splitting it very easily. So here we'll just use air. I get away with a little bit of WD-40 every once in a while, but I don't spray my cutter. 50 thousandths, 16 inches per minute. That 2-flute cutter keeping the chips clear. A lot of clearance for the chips to get out of there. And our shop air is keeping our slot clean as well. If you let that plug up with chips, your cutter will snap in half. Okay, we're going to go down to 882 and then we'll see you when we're ready to clean everything up. Then it's going to get real exciting. Someone just called me and said I said 882 or 1690 or something like that. I don't know where all that came from. However, we constantly refer to our drawings, and I meant to say 1290. So let's get a measurement. Remember, we have deburred that. Make sure there's no chips on that. We're at 0. This is accurate enough. 1293. Looks great. Now we've made our slot. Now this needs to be 130th. 130 thousandths. So we're going to move our cutter over and clean that up until that's 130 thousandths. And then from here to the back needs to be 670. So we'll make this 130 thousandths. We'll deburr this so that we can take a measurement from here to the back, and then we'll clean this up until we are 670 thousandths from here to here. Then we're going to move our cutter in behind, because this part right here needs to be 130 thousandths. I've taken a measurement on this. This is 149. We want it to be 130. And so we'll just take 19 thousandths off of it all at once. That'll be good enough for this job. We have our cut done here, 130 thousandths, and now we need to clean up this back and get that measurement done. So we're going to find the back with the cutter. There it is. Move out of the work. We'll take 30 thousandths or so. Again, we're climb milling, so very important to have the table lock. Okay, I've moved in 20 thousandths. So now we're cleaning up the back. This is conventional milling. This has a tendency to chip weld, so I'm going to put a little WD-40 on there. Makes for a nice cut. And now back the other way. After this cut, we'll measure from here to there. We want 670 thousandths. I don't use the WD-40 when I'm twine milling. There's a lot of chip clearance and don't have problems with welding chips back onto the work. In order to measure, I need to get rid of this burr. .670 is what I'm looking for. And that's 664. Making a beautiful finish. Okay, we're in behind the work now. We've got to make this 130 thousandths. So I'm going to find my work by touching it, and then we'll keep milling 50 thousandths or so at a time until this is 130 thousandths. We'll keep checking it periodically and creep up to it. Hope that shot works out. Looks pretty cool. Made the table lock tighter because we just pulled some of the backlash out. If you didn't see it, you can back the video up and see that little lump that formed in the work. Pulled out a couple thousandths of backlash, so I've got the table lock pretty tight. This is a very big, tall cut, and we're climb milling in this direction. We'll use WD-40 for the conventional milling the other direction. 30, 40, 50,000, something like that. Let's see what our measurement is on here. We're looking for 130 or so. At about 168. So we've got 38 thousandths. I'm going to take off 20. And measure again. We want to creep up on this. If you creep up on this, you can hit it dead on if you're careful. Pretty close to dead on at least. Right now we're at 134 thousandths. The work is pretty warm. I would say it feels like about a 108, 110 degrees, something like that. So it shouldn't shrink too much cooling down. So I think we might get by with moving the y-axis a thousandths or two and trying for a spring cut. I've got WD-40 on the back because we're conventional milling. This should give us a nice finish. Be nice to finish with a climb mill, but with the WD-40 running at this speed with carbide, with a nice sharp cutter, it'll come out nice. Let me cut it and we'll measure it again. Okay, we took off a thousandths or so. We're at 133, so it looks like we will be able to finish with the climb mill. I won't use any WD-40 on it, and I'm not going to move the y-axis at all. We're just going to try for a spring cut. That cutter is hanging out of the spindle about that far, so when the work hits it, it has a tendency to bend and move. And so if you leave everything where it is, the cutter will spring back. So that'll cut a thousandths or two more out of your work without moving it. Let's see how that does. We've got about 132. I'm going to stop there because it's 130 plus or minus 5. That work may change a half a thousandths or more when it cools. I don't want to go below 130. These are the little wispy chips we got off from that spring pass as the cutter and the work were springing back. Just barely there. Little bitty, little wispy threads. Pretty cool. Okay, let's go put this on the bench and measure accuracy. Okay, I've got the micrometer set up just for kicks and jiggles. We are at 132.5 thousandths on this side, or so. And 132.5 thousandths or so on that side. See how the middle came out. $134.5 or so. And let's check in between the end and the middle. That would be at quarters. I'm just using the slip stop here. What is that? 133.5, and then a quarter over here. 132.5. Very nice. I want to thank you for being with me today, coming along on this little journey, watching us make this part. Hope you enjoyed it, enjoyed being with you, enjoyed filming it, and hope to see you next time. David Dominesi, have a good day.